Good. Fantastic. Classifying a photo of property into a particular type. Nested are an online estate agent. Quite a lot of their business is valuing properties based on comparables from other properties online. So their agents have to look at properties and they want to find the right image. And they spend quite a lot of time sifting through 12, 16 images for a property to find the one of the kitchen, the one of the front. Question, can you sort that automatically? Answer, 90% plus of the time, yes you can. Okay, so that's where this goes. Data is about 20,000 images, scraped off Zoopla and Rightmove, labelled questionably, more of that later, via Amazon Mechanical Turk. They look like that. So, I've gone cross-eyed at sometimes going through thousands and thousands of images like this, but lots of them are fine. That's a bedroom, right? That's a kitchen. That's a kitchen, that's a bedroom, that's a bathroom. What's that?
That's a studio. Living room.
Yeah, but it's a living room, but there's also a dining room, and it's also a kitchen.
It's a studio.
Standard London flat.
Standard London flat, but studio's not going to cut it because you can't compare. So you want to label this as a room, right? More on that later, but that's sort of the way into some of the data issues. So the approach in here, we've done neural nets, we know all about that. Pick up one of the models because no one trains a neural net from scratch anymore, not on our budgets anyway. So went to the Inception v3, which is one of the later Google ImageNet classifiers, and a process of then transfer learning and fine-tuning on the upper layers of that to build the classifier. I kind of did some learning on the cats and dogs data on Kaggle, which was a good place to start, and then let loose on here. This was running on quite a hefty Google virtual machine, so a 16-core, 104 gig machine in the cloud. One run was taking about 12 hours on that. So the workflow here, a lot of processing and reviewing the data. Actually running the models, once you got the machine configured, was largely a hands-off, just let it get on with it. Making the predictions and then taking a look. What's the key activity in there? Well, actually there's a bunch of stuff that's got nothing to do with running the models. Setting up one of these Google virtual machines, I wrote a blog, some of you read it, big learning. And that blog is only part of it, because actually then you get into it matters a lot how you optimize TensorFlow. So just installing TensorFlow works, but actually spend a bit of time getting it better, and it works in less than 40% of the time. So it matters a lot when you're paying per minute, right? And then how do you take a file structure of 20,000 images plus some code, pack it up, lift it onto a virtual machine, do your work, and then take it off again, because you don't want to leave it there when the machine's off, because that costs money as well. So a lot of learning around that. There's a part 2 to the blog coming at some point. Working with big image libraries. We hadn't done that. All the data we've done has usually been in tabular form. So it's nice and easy. You do a train test split, it all works, everything's handled randomly for you. Now you've got 20,000 images sitting in 11 folders, which is how this stuff takes thinking. Okay, how do you work with that? I actually then discovered a lot about pandas is fantastic for cataloguing this stuff. So you can run recursive walk through 20,000 images, catalogue each one by its image path in pandas in a fraction of a second. And then you can strip out all sorts of information from the image path about the label, and you can add all sorts of stuff to that image path about, is it mislabeled, is it reclassified, what's the prediction, all sorts of stuff. And then you have a fantastic mechanism for screening and masking and doing all you can do with pandas, and then you just go back to the image path to pick up the actual image to do any prediction on. So working with big sets of data, cataloguing in pandas, I just found a complete godsend.
Is that another blog post?
Sorry?
Is that going to be another blog post?
It will be, actually, yeah.
That's cool.
There's a 3-blog sequence about this project coming, that's one of them. Another one, all of this, those image grids, you see, a lot of this comes from looking at grids of images. You can't work on evaluating images just on numbers. You have to eyeball them. Okay, so I found I needed something that could plot, okay, well, do me a grid of 50 of these images, kind of 16 by 8, randomly picked that meet these criteria, and then do 10 of them. So I can just take a look quickly and compile. So actually quite a lot of the code I wrote was around the function to build those grids and keep a catalogue of what's in them and set them in any size and all that kind of stuff, and so randomly sample. Labeling the test data, quite a lot, again, using a model to label stuff takes a bit of work. The actual Keras TensorFlow stuff, yeah, you've got to take off the top layer and reconfigure it. There's quite a lot of that online. There's far less on the other stuff, actually. So most of the learning was around here. This stuff, it's fine. Transfer learning, fine tuning, there's lots of code. Loss curves are important. Callbacks matter a lot. I discovered, I think David is doing the same thing. So callbacks are, as you're running the model, save the model each time it does it, or every couple of epochs. Keep track of the training log. Otherwise, if you set it going for 32 or 64 epochs, you get nothing until it finishes. And if that's 24 or 36 hours on a heavy-duty Google machine, that's quite a lot of money. Some data challenges. Okay. So, the data labeling was so-so. Partly the labels were ambiguous, partly the labeling just wasn't good quality. But here's some good one. What's that?
That's an entrance.
Is it? It was labelled miscellaneous internal. It's not a conservatory. For all sorts of building reg definition, it's not a conservatory. It's miscellaneous. That was labelled miscellaneous internal. What's that? That was labelled a kitchen. Is it? Or is it a dining room? Or is it about half and half?
There's a stove in the background.
Yeah, but it's still, most of the images are dining area. If you turn around and took it the other way, it'd definitely be a kitchen.
Potato.
Is that an entrance or a well, it matters a lot, of course, when you classify it. Here's another classic one. Is that a dining area or a kitchen? Or is it both? And what's that one? That's kind of through a doorway, half and half. Okay? Turns out, actually, the model is better at labelling this stuff than humans. So the training, there was a transfer learning run, there was a fine-tuning run, the dotted are the validation lines, the solid are the training lines, loss and accuracy. Transfer learning, after about 20, wasn't showing any improvement, so I picked up the kind of best save point in the run here. You arguably could have taken it back here, but I don't think I had quite the right one saved. Fine-tuning, running slightly different, much lower learning rate, running on stochastic gradient descent. And again, this stuff rather nicely shows overfitting. There's a point at which the train loss continues to decline, but the validation loss just flattens off or even kind of gets worse. So beyond there, you're overfitting, arguably, so you just take that one and that's the model. Each one of these models is about 170 meg when it saves it, so saving it every epoch becomes a little bit intensive. Test the data. Again, take that model, make the predictions. That gives you a big probability array. And again, if you're doing that on kind of 4,000 test images, that's a bit hard to handle. Again, Pandas is great for handling this stuff. Take those labels, put them in a data frame with the probabilities, a bit of code to extract the top three and the top three labels and put that back into the data frame catalogue of the test images. All of which then enables you to kind of go into the test images and say, well, show me the ones that are right, show me the ones that are nearly right, show me the ones where the second most probable label is right, etc. So these are labelled, these bars are proportional to the probability, so it's all the way across, it's a 1. Okay? And this is great. Bedroom, bathroom, dining room, which is a dining room, no doubt. Kitchen, fine. How about that one? It's labelled that as a living room, but there's a dining table. So, well, actually, he's labelled it as, I think, I can't read the number there, but 82% living room, 17% dining room. That's not bad, actually, in the description. I'd go with that. If you just take the first label, straight accuracy is 85%. If you look at the confusion matrix, on the rooms that matter, the bathroom and the kitchen, it's well into the 90s. And if you look at what it's confusing it against, it's sort of kitchen versus dining room, so that's great anyway, that's all matches. But what about the problems? Here's a bedroom. What does it reckon it is? Living room empty or bedroom? Well, this one, that's kitchen, labelled. It reckons dining room 87, kitchen 26. Again, I'd buy that. This one, classified as entrance, actually comes back as miscellaneous internal or entrance. Comes back as dining room, living room mix. You can start to see the challenge here, actually. These things need more than one label in many cases. If you go in, and what I did slightly fudge this, is to say, well, look at any of the top three labels that shows me more than 10% probability and take those. And if one of those is right, class it as accurate. So if you basically label all these images with anything more than 10%, is it right? Suddenly your confusion matrix lumps into the nearly 94%. And again, on the rooms that matter, you're into the high 90s. So again, the actual objective, which is taking an image feed and having a pretty good stab for the unknown valuer, here's the living room, here's the kitchen, boom. It's going to do pretty well. Most of the further work comes back to the very start and look at the image, right? Label it better, label it more reliably, label it multiply. You need some voting on this stuff. One label per person, you need to get these things labelled 7 or 9 times by different people, vote on them and take the majority and exclude single votes to get them accurately labelled. And I think, David's going to talk in a minute about classifying internal, external. I think you could do this in one shot and take all of the external and all the internal photos and classify them and go. I think, I haven't tried that, but I'd be pretty confident. That's me.
Awesome.